that worked that time. So I'm doing this test run because we're doing this mathematics thing. Saturday. Yeah, Saturday. I'm doing a mathematics thing Saturday. I used to help do this math group a couple years ago, but then I moved away from the Philadelphia area, so I haven't really worked on it as much. But because of the fun that is going on right now, we've switched it over. So I'm going to just play around a little bit with this. Right now I'm on YouTube because I'm pretty sure nobody follows me, and as I can see, there's currently 0 people watching me. So we're just gonna like play with this for now. I'm gonna get used to it a little bit, and then what my idea is that I can sort of share a little bit and go live. Hopefully later today. Hopefully later today I'll actually try to go and do Facebook. So, yeah, I'm kind of playing around with the setup at the moment here. So, first problem that CJ has written down is, according to Wikipedia, the pigeonhole principle states that if n items, if n items are put into n containers, damn it, yeah, I know. See, this is the reason why we're doing this test on a thing that as far as I know, nobody's actually seeing. And so I can make weird little mistakes. If n items are put into n containers, m containers, there is got to be a better way to write this, with n greater than m, then at least one container must contain more than one item. Well, then at least one container must contain more than one item. Yeah, that makes sense. So if, let's say, 2 items are put into one container, then yeah, then we can see that that one container has, oops, no, I got this weird thing going. One container has 2 items, and we can we can increase this a little bit and say if 3 items are put into 2 containers, then one container has 2 items and one has 1. Right. And so we're going to see that if as long as this holds true, that n is equal to m, then I know my handwriting is awful in this section. Okay. I'm just getting used to the system. Yeah, okay. So as long as n is greater than m, then m will contain multiple to look at it. Hey, how do you erase this? I just want to like delete the whole thing. So I'm pretty sure nobody's watching this at the moment because I have no followers. Yeah, I have no followers. I have 1 follower on this account because that's I I really have no idea who that one follower is. But so we can just continue to sit here and be, kind of have this like really weird, stilted son of a bitch. We can just continue to have this weird, hey, awesome. Hey, cool. There we go. What the fuck? Oh, right. That was an earlier mistake thing that I have no idea how it happened. X. No. There we go. I have no idea how that happened. Why isn't it erasing? That's cool. Why aren't you erasing? Erase. Erase, damn it. I'm Gumby, damn it. Oh, that's because my eraser side isn't working like an eraser. That's why. Can I just increase it? Maybe that'd be really good. No. I just. There we go. There we go. Okay. No, that's a pretty simple principle to sort of get to wrap our heads around. In that, if n is equal, so yeah, that's a pretty simple principle to sort of wrap our heads around. So that when I think Mei-Yu Chung has. I think Mei-Yu Chung has the actual fucking set theory written down, like how to actually write this. So I'm gonna have to look this up in a little bit. Where n is greater than m. What is it? Oh. So the idea, so I think that's exactly it. I think she describes it as a set. She describes the concept as a set, whereas like M is a set containing n. It's been so long since I've done set theory, I can't remember how to write it. Where n is greater than m, m will contain multiple n's. So I guess, she did the Venn diagram thing. I don't know. I can't remember. Anyways, it's a pretty simple thing to sort of figure out. Question one's pretty simple to figure out. Because, all right, you gotta this nonsense. I'm getting the hang of this layout. Okay, I'm getting the hang of this layout. Now this is exactly what we wanted. So, because the idea is let's say n, so n is greater than m. In that case, if n equals 3 and m equals 2, and we have a box, and we have another box, which are containers, we're going to find that in 2 containers and 3 items, you're going to have, let's say, there's going to be, this is a butt plug. So we got 1 butt plug here, and we got 2 butt plugs in this container. And we're going to find that as long as n is always greater than 3, I think we're going to find that in our experimentation that we'll always find that that the idea that then at least one container must contain more than one item should be justified. So, but that brings up the question though, because it says at least one. So what happens if we do multiple? What if we do like a weird odd number? Like let's say n equals 10 and m equals 9. Yeah, then the question becomes, how do we divide up 10 how do we divide 10 butt plugs into into 9 butts? How do we put 10 butt plugs into 9 butts? How many people are watching this? Nobody still, right? I'm still alone. I'm still alone. Awesome. So we can be. Oh my god. Now that I'm kind of like getting used to this and like, oh yes. Okay. No. Yeah, okay. So yeah, we're good. I'm loving this. Okay. So once we get, so the question is, how do you put 10 butt? So the question is, if you try to put 10 butt plugs into 9 butts, the idea is going to be that at least one butt has 2 plugs in it. Because we're gonna, the idea is, the basis of it is that we're going to have one left over. Now, the thing is there's nothing in this though about if we can have like part of one. Like, can we have like, can I have like 0.1 of a butt plug? Can I have 0.1 of a butt plug in this scenario? How would you explain it so a child could understand? This is how I'd explain it so a child could understand. Is how I've got this written right here. Oh, that was what I did earlier, and I just never realized it because I probably just did it and just never saw myself do it. Yeah, this right here is how I explain this. And that is, we have 10 butt plugs, and we want to put them into 9 butts. Can we distribute that evenly? Well, and then there are situations where you're going to have multiple, where you'd have multiple. Okay, no, so I like that. That's a pretty simple one. The correct one. So I'm reading question 2 right now. Show that if there are 30 students in a class, then at least 2 of them are born in the same month. That's a classic one. That's a classic one. What are... Damn, there's a question I've heard before. That's the, what is that, the birthday problem, I think? That if there are 30 students in a class... Well, of course, the way that works is, we're saying that in a class, everybody's approximately born within the same 12-month period. For example, my class was made up of kids born between, I think, August of 1987 and I think the cutoff was June 88, like June 16th of 88, I think was the cutoff for it. Yeah, I think it's like between like August 20 something and June 16th or something like that. Something like that was the cutoff. Hmm. Okay.